In this video, we will review multiplication and division of fractions. Multiplication is by far the easiest operation to do with fractions. To multiply two fractions, you simply multiply straight across the top and straight across the bottom. In other words, we multiply the numerators together and we multiply the denominators together. So to multiply the fractions 9/8 times 5/2, I simply multiply 9 times 5 up in the numerator, which is 45, and 8 times 2 in the denominator, which is 16. In the second part, 2/3 times 5/4, again it is a multiplication problem, so we multiply the fractions straight across the top, straight across the bottom. In the numerator, 2 times 5 is 10. In the denominator, 3 times 4 is 12. At the end of any fraction problem, you do need to stop and check, can you reduce your fractions? In part A, 45 and 16 do not have any common factors, so that fraction is already reduced. In part B, though, 10 and 12 do have a common factor of 2. I can rewrite 10 as 2 times 5, and I can rewrite 12 as 2 times 6. Because they have a common factor of 2, I can cancel that common factor of 2 out of the numerator and denominator, which would leave me then with the fraction 5/6. Some of you may have learned the process of cross-canceling. So to take a second look at this same example, 2/3 times 5/4, you are able to cross-cancel when it's a multiplication problem and there is a common factor in the numerator and denominator of two of the fractions. In the beginning, I noticed the numerator of 2 and the denominator of 4 both have a common factor of 2. If I cancel 2 out of the 2 and 2 out of the 4, I can reduce the fractions before I multiply. If I now multiply straight across the top and straight across the bottom, I now have the numerators 1 times 5, giving me 5, and 3 times 2 in the denominator, giving me 6. Notice I obtained the same 5/6 fraction at the end, but I did my canceling a little bit earlier. The trick with cross-canceling like this is that it only works with multiplication, not division, subtraction, or addition, and it only works if there's a common factor to both a numerator and denominator. If you choose to use cross-canceling, please do so very carefully. Division is the second easiest operation to do with fractions. The trick to dividing fractions is to first rewrite the division as multiplication by the reciprocal. So in part A, we have 9/8 divided by 5/2, so what we need to do is keep the 9/8 the same, but we turn that dividing by 5/2 into multiplying by 2/5. And now that it is a multiplication problem, we can return to our multiplication process. Multiply the numerators together, multiply the denominators together. 9 times 2 in the numerator is 18. 8 times 5 in the denominator is 40. Again, there is a common factor to 18 and 40. Both of them are divisible by 2. 18 is 2 times 9. 40 is 2 times 20. And so we'll cancel out those common factors of 2, leaving us with 9/20 as our final answer. In part B, 2/3 divided by 5/4, we again will start by rewriting the division as multiplication by the reciprocal. Again, the first fraction, the 2/3, will stay 2/3. The fraction that you're dividing by is the one that is turned upside down. Since we are dividing by 5/4, we will multiply by the reciprocal, 4/5. Again, it is now a multiplication problem, so I can multiply the numerators 2 times 4 to get 8, and the denominators 3 times 5 to get 15. 8 and 15 do not have any common factors, so I cannot reduce that answer. When we formally state how to do something like multiplication and division of fractions, we want to do so without any particular numbers being used. So to state the general way that we describe how to multiply fractions, we take two fractions, a/b and c/d, and we multiply them. a/b times c/d follows the same process. We multiply straight across the top, straight across the bottom. In the numerator, a times c gives me ac. In the denominator, b times d gives me bd. So a/b times c/d is ac/bd. There are some restrictions though. Anytime we're working with fractions, the rules that we state only work as long as there is no denominator of 0 used anywhere in the operation. So this is true only as long as b is not 0 and d is not 0. For the general way to state division, we'll start with a/b and c/d, but we'll now divide them. So a/b divided by c/d is rewritten as A over B times the reciprocal, D over C. Now that it is, again, multiplication, we can multiply the numerators, AD, and we can multiply the denominators, BC. Again, because we're working with fractions, we always need to be careful about any denominator having been a 0. So this is true as long as there's no denominator having ever been 0. In the beginning, B and D were the two denominators, so neither of those could be 0. But after we multiplied by the reciprocal, C became a denominator, so in addition we need to specify that C could not have been 0 either.